So how big are nanoparticles? To put their size into perspective, most nanoparticles are about a millionth of the size of a pinhead, like this one. At approximately 1 to 100 nanometers, they substantially increase particle surface area, which improves the dissolution rate of a synthesized oral drug, for example.
The study of nanoparticles and nanoscience in general is currently a very well-researched topic, and is of popular interest within the scientific community. In fact, the University of Sydney has an entire building dedicated to the research area. This is also known as the Sydney Nanoscience Hub. Over to you, Belinda.
Over the semester, we've been studying the interesting properties of silver nanoparticles. In fact, we can see here that when the silver nanoparticle size is limited, a wide range of colours are observed, because as the size of the nanoparticle changes, the frequency of electron vibration, called plasmon frequency, changes, and as such, ultraviolet and visible lights of different colours or wavelengths are absorbed. The electrochemical properties of silver nanoparticles are also vastly different to their bulk counterpart. While bulk silver is an oxidizing agent with a reduction potential of 0.8 volts, silver nanoparticles are completely different. They're a reducing agent with a reduction potential of minus 1.8 volts. This has some very useful consequences. Polyurethane foam, Kevlar, and a range of pharmaceuticals all contain a functional group called aniline. Here's Xander to tell us more.
This is what aniline looks like. However, producing aniline can be a tricky process. This is where silver nanoparticles come in. Starting from another organic compound called nitrobenzene, the low reduction potential of silver nanoparticles is exploited to reduce the nitrobenzene to aniline in the presence of sodium borohydride via a process known as electron relay. Here's Annie to expand.
Without the silver nanoparticles, no reaction would occur. We demonstrated this process in the lab by adding silver nanoparticles to an aqueous solution of 4-nitrophenol and sodium borohydride. We then used an analytical technique called ultraviolet visible spectroscopy. The principle behind UV-VIS spectrometer is quite straightforward. A beam of visible light is separated into its component wavelengths by a prism. Mirrors are used to lead the beam to pass through a cuvette containing the sample we want to measure in a transparent solvent. Another beam is then passed through a cuvette containing only the transparent solvent, and the two beams are compared, much like EAS.